So let's talk about the different types of seismic waves that move through the Earth. And remember, these begin at the focus of the earthquake, but they literally travel throughout the entire Earth, and we're able to record those at seismographs all around the world. The first one of these is called a P wave, and these are compressional waves. So probably one good way to think about a P wave is imagine if you attached a slinky to a wall, you had your hand on the other end, and then you just pushed on the slinky and then went back to the position you were at the beginning. What you would see is that you would get the coils of the slinky getting closer together, and that would kind of move down towards the wall from time 1 to time 2 to time 3. Behind that, you would get an area of expansion, and that would also move down the wall, in this case from time 2 to time 3. And even though the energy is moving through the slinky is still at the same position when all of these waves have moved through as when you started. So it's just the energy that's moving through the Earth. We're not displacing particles of the Earth through the Earth. We're just having this energy propagate through the Earth. The P waves are the fastest waves. They're the first to arrive, and they're also typically the smallest waves. Let's compare that with an S wave. So now instead of a slinky, let's tie a rope to the wall and then just kind of give the rope a little snap. And then we would see this waveform of particle motion move down the rope from your hand to the wall. And so from time 1 to time 2 to time 3, once again, at a later time, everything's going to be back in the same position that it started with, right? So the rope itself has not moved down towards the wall. It's only been this energy associated with this wave form that's moved down the rope towards the wall. And those are how S waves or shear waves occur. So S waves are ones where the energy is going up and down like this, and they tend to be larger than the P waves. They're a little bit slower in propagating through the Earth, so they always arrive after the P waves, and they are capable of causing more destruction because they are larger waves. The other type of seismic energy that moves through the Earth is this thing called a surface wave, and this is most analogous to a wave in the ocean because the particle motion of the rocks is kind of in this elliptical type pattern. Once again, the particle itself, this piece of rock, is ending up just where it started, but the way the energy is propagating is it's moving in this elliptical pattern, which is setting up a waveform on the top of the land here, and that's actually going to move over time from this position over to here, over to here, over to here, and just kind of like from left to right across this. So it would look like a wave from in the ocean, except it would be moving across the land. These surface waves are the slowest waves, which is good because they are the most destructive. Sometimes we actually can send out early warnings before they get there, but they are the most destructive, but they are the slowest as well, and they typically have the highest amplitude, or they're the biggest things to appear on the seismogram.